Hello, morning everyone. Hopefully I pressed all the right buttons. Great. Okay, it looks like it's start time. That so let's get underway. No nice pictures from this morning. It was sort of overcast, and I'm back in Kingsburg this week. But was it Sunday morning? Yeah, we had quite the storm Saturday night. It was very noisy here, and this is what it looked like first thing on Saturday or Sunday morning. That huge waves everywhere. That the breakers were just monstrous big things and went on most of the day. Um, that the winds weren't high any longer, but the sea had been really stirred up with the storm that we had that night. And it was nice with the way the sun was coming in the morning. Uh, Fresh new day type of feel to it. And so we headed over to Hurdles Beach, which isn't that far away from us, for a walk, Dora and I, that morning. And there's Dora out there at Hurdles, and the breakers there were absolutely massive. This was before people started showing up. I'm sure in the afternoon, the beach was quite crowded with people that would come down for the waves. Uh, Out behind at Gaff Point, that was out there, the sea spray you could see out there was absolutely enormous. So it was a lovely day, though. And Members of the class have started sending me in pictures, and I'll start adding one or two of them to each class as we move forward now. And so looking back to one that most of the students, I believe, are in Halifax, although some of you are elsewhere in Canada and a certain percentage of you are elsewhere in the world. Uh, and if you're in your first year and you're in India or elsewhere, that maybe you don't know what Halifax looks like, that this is said Halifax is a peninsula, and we have two container piers. I showed you a slide last week, which is back in Fairview Cove, which is our inner harbor, and there's a container pier there, and then there's a container pier that's right at the end of the peninsula of Halifax, um, closest to the ocean. And for trains to get to the where the main port is, there's a railway that runs along one side of the peninsula, and given the geography and the like, it's been cut through rock fairly deeply, and this rail cut loops around one side of Halifax. And this is a picture of that rail cut, and you can see the feeding out towards the container pier, and it's very close to where St. Mary's is. That one side of St. Mary's backs onto the rail cut. Um, if you know the campus, if you know where Loyola Residence is, if you go into the woods behind that, there's a house, a Stanfield house, that you go in behind it, and in behind there, you get to this rail cut. And St. Mary's owns a huge amount of property that loops around behind houses and everything else along the side of the rail cut. If you're on campus and you want a nearby spot that's quiet, peaceful to walk, and you've got good shoes on, because it's a little bit rugged, there are some really nice little trails back through that space, and nobody seems to know about it, except Friday night when the junior high kids go there for drinking. But it is a nice, quiet, peaceful spot right by the campus. That, as I said, very few people know about it. I was at St. Mary's for 15 years before I ever discovered it. A bit of administrative update. We're into Excel today. Your first assignment. Plan on launching this week. It'll be due at the end of next week. And the Math Help Center is going to be up and running starting today. That uh, they should be able to help you online. They've structured things in a variety of different ways of a virtual study hall, peer study sessions. There are tutors there that are available. And so I posted some information on Top Hat. It's if you go your content tree up where the course outline is posted there. Right next to it should be information on the Math Help Center. And, it's not to say you can't come to me for help. You're welcome to get after me for help all the time, but they're a good resource. The other section of the class appears to have formed a Snapchat study group. And I guess they had one last term, or many students did. And students have been just sharing their Snap IDs through the chat window here. I know nothing about it. I don't know how you find this study group that they formed, but I know the 8:30 class has formed one. And they said that it was very helpful last term to have one. That I don't use social media at all, so I'm totally ignorant about what this resource is and how they use it. But I encourage you to find these types of virtual ways of interacting with one another. Um, that okay. Great. Okay. So James has put information out there and get things rolling. As I said last term, at least from what I saw in the chat, that's all I'm following. Uh, they said it was useful to them, and I encourage you to use those sorts of things. That the so we've said we start out defining a business problem, and then from that we try to identify specific questions that if we can answer the questions, maybe we can solve the problem. And then the data that we might use might come from an administrative database, might come from a survey, might some combination of that type of thing. Generally, the data that we have isn't exactly what we're looking for, but it may be close enough that we can get by. And we may have to have some caveats about be careful because it isn't exactly what we wanted. And generally that data is messy, it's dirty, it's incomplete, and we're going to have to do some work to make it um, uh, function appropriately for us. And so today we're going to start in with finding some data and working with it. So, and we're going to be using Excel for all of this. And that Excel is not a real data scientist might use Excel like you would use a calculator. It's something on the side, but it isn't their main tool that they would use. They have very sophisticated software available. And if you get into this field and go further, you would start getting into that. But Excel is very accessible and everybody's got it on their desktop. And it does do a lot of quick, simple things. And that we're going to be exploring what we can do within Excel. We'll also be noting what we can't do within Excel, but we can do an awful lot there. But it's got its limitations, and one of them we'll mention in a minute is issues to do with protecting your data. So we'll work through a variety of data preparation type tasks, and this will be related, may assist us as we go through that with our data understanding what we've got. And we're going to look at specific tasks within Excel today, and we'll be adding on more things as we go. I'm assuming you have not done Excel before. If I do things that you don't understand, you're unfamiliar with, then ask me, and I'll go back and do it again. Don't be shy. That within Chapter 2, I've embedded a couple of how-to videos using Excel, and you will see that in some subsequent chapters. And if there are areas I don't cover and maybe should have a how-to on, then let me know and I'll build one. It's pretty easy. So first off, before the Excel, I'm going to talk about just data and the importance of getting a feel for your data, to look at it. And I'm a very visual person. It isn't just numbers, I need pictures. And COVID is a nice data set, readily available. We hear about a lot. And there are a number of published sites where you can download data. simple ones that are easy to use are on MSN in their news channel, and similarly with Google in its news channel. If you want authoritative data, then you can go to Johns Hopkins University. And a lot of the stuff on MSN and Google actually are coming from Johns Hopkins. That I just like the graphics that are there. They help me understand the data. So just to show you, maybe widen this a little bit, see the end of my graph. This is data taken from MSN, and it's been charting. You can look at daily counts of stuff. I'm looking at daily fatality figures, and this is for the United States. You can drill down by the state and probably further than that, probably drill down by county even, I think. But you can see on here that this was our first wave in the spring, and then things started to get under control. Everybody started opening up, and in the summer, all kinds of problems hit. And so they started getting it back under control again. But as we got into the fall, we had holidays. People were getting impatient with lockdowns and closures, and socialization took place a lot more. And then over Christmas and New Year's. And so we're into another big, big, big wave. And these are not just the case count, these are the deaths that are here. So we're getting up now to 4,000 a day on some of those days. But look at it. It's not a smooth picture. It's a sawtooth that goes, um, got all these gaps. And it's like a gap, and then it goes, even this bit is a sawtooth. It's like a blade. It goes downhill, and then it's got another gap, and then a sawtooth. And this repeats itself pretty regularly, a bit more jagged out here. Any thoughts what's going on? Why this is happening? Do people prefer dying on some days of the week than others? Any thoughts? Yes. Pick anything. First thing that comes to mind. Got a few typing. Weekends. You got it. It really is weekends. There are many states in the US that don't do any reporting on the weekend. So all of the Saturday, Sunday deaths get reported on Monday. So we got the trough, and then boom, Monday it goes up higher. It trickles down through the week. Some of them are late reporting, and so they show up on Tuesday or Wednesday. Then by Thursday, we've probably got an accurate count. Then we're into the weekend, and it drops again. So daily data, be careful about interpreting variations from day to day. It's not a good thought. You should probably, with the US data, look at it weekly. But you wouldn't notice that if you didn't look at pictures like this. And we'll see through the course. I try to use pictures to help us because most of us are much better visual learners than number type learners. Here's the Canadian data. We don't have the weekend problem. Our provinces seem to be better at reporting on weekends. And particularly the big provinces, Quebec, Ontario, BC, report through the weekend. But it's very, very jagged. Part of that is smaller samples. We're getting up to 250, whereas the US is getting up to 4,000. So the US, the numbers are 10 times bigger. As you get smaller numbers, they tend to bounce more. But look at these massive spikes, and then boom, crash down afterwards. And here, another massive spike. A couple of days. These are probably holidays. Yeah, these are maybe Christmas and New Year's where there was no reporting taking place anywhere. Any thoughts about the huge spikes? What happened there? Any quick thoughts? Nobody's typing. Well, to keep us moving along, I'll give you at least a partial answer. I know a couple of them had to do with cleaning up their data. In one instance in Quebec, there were a number of hospitals that were not consistently reporting. And the province got after them and collected all their data, and then we had a spike. And this might have represented activity at a smaller hospital or several smaller ones that had not been reporting, and they all got reported in one day. So this wasn't one day's results. It may have been 2 weeks or 3 weeks of data. There were others that went back uh, and re-examined their data or re-examined the fatalities. Uh, and they may have initially been categorized as being COVID, but then on closer inspection, they realized no, cause of death was something else, and it was misclassified. And it was just sort of a first thought that, oh, must be COVID, must be COVID. No, a number of them weren't. And then there were others that were reclassified as COVID deaths that they had initially put down to do with lung failure or something, which is very close to being the same. And so that led to, when they're doing the cleanup, sudden spikes up. What isn't shown here is there's actually days, and I guess this data on MSN has been cleaned up further. There are a bunch of days with negatives. It happened mainly during the summer months when the numbers were very, very low on deaths per day. We had a couple of days where we had -5 and -8 deaths. And it's because when they did the cleanup, they realized they'd misclassified some as COVID. And then to correct the totals, they had to make that show up as a negative number to make totals work out right. So be careful about your data. Sweden is one that I was watching a lot because in the spring they didn't enforce social distancing, masks. They kept bars and restaurants open. They felt if enough people got infected, they would have herd immunity, and that would solve the problem. And they said the death rate was quite low, so yeah, what's the big deal? They're going to die anyway. Anyway, if you, they did find that in comparison to Norway, Denmark, Finland, the mortality rate in Sweden was significantly higher. This idea of keeping everything going turned out to be a dangerous phenomenon. They've also got issues to do with their reporting as well. But and as they've gotten into their second big wave out here, it's very bizarre results coming out. I don't know what's happening in Sweden, but it's been an interesting case of among developed countries, and particularly among European countries, they went down a very different path in terms of what measures they were taking to deal with the virus. So these are examples where I'm consuming data and trying to be an intelligent and critical consumer. And most of the time, we are going to be consumers. We aren't producers. That a small fraction of the class may become data scientists and become producers, but you're all going to be consumers. And to be a good consumer, critical one, you should have a sense of how do the data scientists produce the data, and so that you can have that critical lens on looking at this stuff. So let's start going through that. And we're going to be looking at some data, so let me give you the context for the data we're going to work through. We're using a data set from 10 years ago that I happen to have back when I was a registrar. And it was part of a national survey of students. And that I don't have a lot of detail on that one. I've lost all my records associated with it other than the data file. But when I first started saying, is there anything interesting here? I became intrigued by looking at the expectations of graduates. How much did they expect to earn when they graduate? And are there patterns here in that? Most research that's out there about graduate earnings has to do with how much they actually earn 2 years and 5 years after graduation. There's been very, very little research done on what did they expect to earn, and do they have realistic expectations? And we're not going to get into that because we don't have the actual earnings. But I'd like to know, are they similar? Do art students expect to earn? Do they know that they're going to earn less than an engineering student or a business student potentially? Uh, are they aware of it? Do they recognize that? Do they expect that to happen to them? That currently science students have very high expectations. they're wrong. Science students don't earn much more than an art student does. Um, but are there gender differences? Do males and females expect differences? We know once they graduate and they're in the workplace, we do see those differences. Domestic, international. I'm particularly looking at international that plan on staying in Canada after graduation and working here. Are they at a disadvantage compared to domestic students on that? Um, what are concerns, fears, that sort of thing revolving around it? So I've got a variety of questions, and this is the issue that I'd like to explore. So I've got this big issue about expectations of earnings, and then here are my detailed questions, and I'm going to go and start looking to see, do I have data to be able to study this? So the data, only data I've got on this is that survey from 10 years ago. And now I've got a little bit of data from you because I've asked you some of these questions, but for the most part, we don't have a lot of data available on this. And I've got the St. Mary's data set. This was a national study, 30, 40 universities participated. I don't have their data, but I have the St. Mary's data. And some of them, of the questions in the survey, seem to fit the issues I wanted to look at. A lot had to do with concern about finding any job, finding one in your major, finding one that pays enough, finding one that's where you want to live among people in the Atlantic region. Unfortunately, many have to go away to find jobs. And that's always been the case. Going back 50 years, that was the case. When I graduated from UNB, many people were looking at finding jobs in Fort McMurray. Yeah, the oil patch. They were going to be teachers up there and that type of thing. Uh, that it's been frequently the case that people from the Atlantic region have to go away to find the job that they want. But that's a big concern. So I've got data on earnings, that their guess as to what it would be and how long it would take them to find a job. So there's some of the stuff that fits it. But the questions I posed had to do with comparisons of men and women, of uh, where they're from, or some of those sorts of the types of programs they're in. So one set of data is outcomes, and the other are inputs or demographic characteristics. And frequently we want to see how those differences in demographics affect uh, differences in outcomes. Can they explain some of those sorts of things? So here's a variety of them. You may wonder why I put in parental education. Frequently in studies of students or university graduates, college graduates, high school graduates, socioeconomic class is the biggest predictor of what happens to those people. So if you come from a very privileged, well-to-do family, you're probably going to do well. If you come from an underprivileged, a community that faced social or economic challenges that are discrimination, that type of thing, their outcomes are worse. And study after study tends to show this. But it's hard to collect data or get information on what socioeconomic group you belong to. And so as a rough indicator of that, we use what's the highest level of education of your parents. So if your parents have university degrees, professional degrees, then you're probably at the top end. If your parents only have a high school education or less, you're probably in the bottom group. And so it's an interesting one for many studies. So this data file is on Top Hat. It's posted in the week 2 folder, and you can pull it out, and we will look at it in just a second. And you'll see that the primary things that are there are going to be 3 tabs in a workbook or 3 sheets in a workbook. So let me first go and show you what it looks like. And this is particularly important for these people that aren't familiar with Excel. So let me go, and this is the one. If you opened it, you would find the opening tab is probably this data tab. So along the bottom, these are the different sheets. And think of this as a pad of paper, and I have different sheets, one after another, but the sheets have tabs. They're labeled as to what they are. So this first one I've called data. I think they called it data when I got it. This is all I've got that it was sent to me. It's got columns for different things, and it's got rows, and that's what these sheets look like. The first one has different questions on the survey. Question 1, question 2, question 3, all the way across, and there are a lot of them. So I'm going, some of them have parts, 14 A, B, C, D, 17 A, B, so on. Keep going and going and going. And there's a bunch that are blank. I'm not sure what happened there. And then it gets up to 57. But actually, there's about 100 different columns in this sheet. So each column is a different question, different variable, different thing that we're extracting and analyzing. In last class, I mentioned a flat file. This is a flat file. It's got, each column is a variable, and each row is a record. This is student number 432. Each one had an ID. So for person 432, instead of having their name, I've just got a code for each one. And I have the responses as to what these things are. And there are a bunch of numbers that may not make any sense to us. These look like years, but what are these things? No, this isn't the age. It's something else. That there's another tab called question numberings. Question 1 is, in what province is the post-secondary institution you're currently enrolled located? Okay, so these are Nova Scotia answers. So this question 1, 7 means Nova Scotia. Figure that one out. In what post-secondary institution are you enrolled? Okay, so that's 18. 18 is St. Mary's University. Good, okay. And you can see with each one what these different things represent. Q5, and what type of program are you enrolled? What type of degree are you currently studying? So there's a whole bunch of different things that are in there. But still, even this one, question 5, what type of program? You mean like a business program? Okay, let me look and see what we got here. Question 5. This student was in program 4, program 6, 7, 4, 8. What are these? What are these numbers? Okay. I know what the variable is, but I don't know what its value is. This particular file had another sheet called interpreted data. Thank goodness it was there, because otherwise I wouldn't have been able to understand what this data was. Some of it I'd know, but not all. Question 5, what type of program? Education, visual performing arts, humanities, social sciences, medicine, business. Boom, there we are. So this is first, second, third, fourth, fifth, sixth. So a student that says 6 is a business student. Yep, here's one. This is a business student. This is hard work to be able to understand things, to have to flip through all of these things. Imagine if I didn't have this, I just had the data. Sometimes, and I've had Vincent data files before where I've just got the data and I don't know what any of the things in it mean. I can't do anything with that. So at the very start, when I'm looking at these things, I'm going to need to start tracking that type of information as to what these are. And generally, whoops, we call that a data dictionary. A data dictionary tells me, it explains, like you'd think a dictionary would, of what's in the data set. And this one didn't have one, but I could probably make up one from this data file. That and so to figure it all out, I needed to go through these things that I just did. But these are strange. You know, like when I look at the programs, this is how many students were in each of these. We had 7 in education. We've got 3 that are in law, 2 that are in medicine. We don't offer those programs. What's going on? We'll speak to that a little bit later. But um, right away, I'm starting to see by looking at this and being able to interpret my data and just looking at the raw data, I've got problems. Some of these things don't make sense, at least for St. Mary's. They may make sense for Dalhousie has medicine and law, but it doesn't have education either. It used to. But it didn't in 2010. It hasn't since the 1990s. Um, that other sorts of things that we worry about, I got a lot of variables, but do I really need all of them? That there's so much clutter in here. So just trying to focus on the ones I really need for the questions that I posed, this seems to be a bit much. So as I go and start exploring my data, I'm going to start modifying it. I'm going to change things. I'm going to make it easier for me to work with. So in starting out, I'm going to do some data preparation to make it easier to carry out my tasks. If you do any cooking, it's like getting all your ingredients prepared in advance before you start cooking, doing all the chopping and identifying what spices or oils or vegetables, whatever you're going to need in your recipe, to have them all laid out and organized in advance. So you're not hunting through cupboards or refrigerator to find things and having all this clutter that you have to get around. Keep it simple. Trouble is, when I go and change an Excel spreadsheet, that after I save it, the changes are fixed. And if I realize I made a mistake, I can't go back. I don't have the original anymore. Even sometimes while you're working, the undo function will only undo certain tasks you did, not all of them. And how do I fix when I make mistakes? I make a lot of mistakes. Um, and so uh, my cautionary remarks aren't, they reflect my um, work habits and my mistakes. And a huge number of us make mistakes and we don't realize it until later. And we'd like to be able to go back and fix things. So one thing you might want to do is just start out making a copy of what you need to work with and then work just with the copy. Leave the original alone. Okay? And that's what I'm going to do. And I am going to go and I'm going to identify the questions I think that are going to be useful. These ones on outcomes and these other ones on demographics. I'm going to take them out of my original data and put them in a new sheet by themselves. Okay? And I'm just going to do it by copying and pasting. Let me go back to my Excel. So I'm going to pick out the ones I want. I'm going to create a new sheet and put it in there. What you may notice on this one, and we talked about it in the 830 class, if you go up here to File, that you can protect a sheet or the whole workbook so that you don't accidentally mess it up. So this one here, the data sheet, I guess at some stage I went and protected and I protected it with a password. And passwords are dangerous, particularly when you forget them. And the last class, the student asked, could you unprotect it for us? Good thought. I went to unprotect. It asked me for the password. And I thought, oh, I probably used something silly like password. And nope, um, maybe it was something short like just PSWD. Yeah, that one doesn't work. Um, maybe it's unprotect. Try that one. Hey, that one actually worked. Hey, I found it. In the 830 class, I couldn't think of it. No, it's best to, even if you don't remember it, don't worry. So um, now it's unprotected and I can mess things up. But you can always copy it out of this. I've protected it in the sense that I can't change it, but the protections I put in place on this were ones that I can copy it. I just can't change the sheet. And it was just to protect myself from myself. But let's look at the variables I want. I want their ID. Um, if you click on the column, it'll select everything in the column. So those of you that aren't familiar with Excel or are very limited things, if I start doing something that you can't do or you don't know how to, stop me. I want that column. I also want this column. So I press down Control and click the other column. And I Control and click that one. I want this one. Okay, so let me copy those. Copying, you can go and right click and hit copy, or I can do, I'm old school, we had shortcuts. If I press Control and the C, it'll copy. And you'll notice it puts busy little dashes around each of these. So I'm going to create a new sheet. I hit a plus sign down here for new sheet, and I'm going to paste it in. And I can hit just paste, all different options here. Or I can use my shortcut, which is Control and the letter V. Back in the old days before we had menus and right clicks and left clicks and mice and that type of thing, these were some of the things that we used to use in the early 1980s. So there's some of them. Now let me get the other guys here. I want, whoops, whole bunch. I want 14A to D. These are about worrying about finding your job, salary, and how long to find that job. So I selected all of those, copy it into my new sheet here, and paste it in. Make these bigger so we can see what I'm doing. And then I'm going to go back, and the last bunch of variables I want are way here over on the right. I'm going to be lazy. I'm going to grab all of these ones, copy them, and again, paste it in. And make it a little smaller so you can see the last column. I don't want column 55. It just, so I'm going to go and delete that one. Okay, now I've got the data I want to work with. And I'm going to work with this sheet, and I'm not going to go back and mess up that other sheet that I had there. Okay. So that I've got myself started. I've now got a smaller sheet to work with, not as complicated as the original data one, but it still has these cryptic names at the top, and it's got these funny values in the middle that are hard to understand. So I'm going to start changing it. Before I do, this table I've got, this sheet that I have, if you've used Excel before, you may have used it to build formulas to do break-even analysis, or if you did Quant 1, you may have used Excel to solve linear programming problems. And they had different formats. This one is unique in that each column is a variable, each row is a record. It's that standard format. And I always want to keep it like that as a data file. And Excel has a function that helps make some ways of interacting with a data file easier. And it's creating a data table. If you go up here to insert, I can insert different, I'm going to insert a table. This looks like a table, but I'll insert a table. Excel, generally, if I've only selected one cell at the moment, will guess at what my table is because I know it's not just the 2009. It sees everything looking like sort of like a rectangular box. It notices that the ones at the top are text, and the stuff in here, a lot of it is numbers. Or in this case, it's all numbers. And it goes from column A across to column N, row 1, all the way down to row 812. So this is A1 is this cell, N812 is the bottom corner the other way. And these are labels across the top. It calls them headers. So it already guesses at this. Most of the time it does guess correctly. It doesn't always guess correctly on things, but this one it did. When I do that, it changes the look of it. And it's got bands, makes it easier for me to read across. I don't know if you ever have trouble reading across the table, but which row am I on? And this makes it easier. With the headers, it puts that in a different color, and it puts little arrows. The arrows are neat for doing different things, like Q5. Click on the arrow. It allows me to do sorting. It does filtering. We'll look at that in a future class. It lists all the different values that I have here in this column. They go from 1 to 14 and blanks. And so, and we'll be using those arrows later. Um, but we'll see in a minute, it has other things that are useful to us by working within this table environment. So here's my stuff. I should probably rename it instead of sheet 4, because if I create more sheets, I'll have to remember which one is which. So I'm going to call it grad X. Give it a name, a label. Keep track of what you're doing. Make little notes on what you do, because you forget things. I forget things. Um, that, and even when I wasn't as old as I am now, I'd forget an awful lot of things. Bad memory. So here I've got a better format to it. Let me go back and make sure I'm covering off what's in my slides. So I selected that, pasted it in there, I gave it a name, and I made it a table. So um, that don't worry about these dollar signs that it used. We'll be using those in just a minute. You may have used them in Quant 1 if you did linear programming. We'll get back to it. This is making it easier for me to see this, smaller number of variables, but now I'd like it still to be in not some cryptic type of language. If you did Quant 1, a lot of students would define variables as being X and Y and Z. There's so many things called X. What does this X represent? I like to pick names of variables when I'm building a formula that tell me what it is. So in Quant 1, if X was supposed to represent the number of units of product A that I was making, I wouldn't call it X, I'd call it A. So I'd remember A represents the number of units of product A. I'd associate, or if the name of the product started with the letter A, then I'd pick that A to go with it. It's a good memory trick for you. And you probably did the same. There's nothing special about this X, Y, and Z, and I'd keep away from it. So I'm going to go and give my columns better names because I don't like the names I've got there. So here are the variables I'm working with. These are the names I'm going to give. So Q3 is what year did they start? This survey was of students, all students at St. Mary's, not just first year students. And so we had some fourth year, fifth year, well, some student, the survey was done in 2010 in the winter. So students that started in September started in 2009. They were first year students if they weren't a transfer. But we may have students that started in 2002 or in 1996 in previous years, and they just been at their degree a very long time. But these are all the names I've got. So I'm going to just go into my spreadsheet and I'm going to change these titles. So this is going to be start. This is going to be, oh, I've already forgotten. I think it's program. This one is home. This is how worried you are about finding any job when you graduate. This is about finding a job in your major or a job that has a good salary or a job that's where you want to live. Oops. This is what you think your starting salary is going to be. Oh my God, someone thinks they're going to earn $450,000. We'll look at that issue later. This is how long after you graduate, oops, before you find a job. This one here was your gender. And 10 years ago, we were still just thinking of males and females. Today, on such a survey, you would have other options made available. 54 is age. Okay. So yeah, 18, 20, 25, but you'll find later there's some that are much older. This one here is parents' education. The last one is what language do you speak at home? So this helps me. I don't have to think about what's Q5, what's Q7, what's Q53, those types of things. And it makes it easier for me. Generally, we pick labels that are relatively short because we'd like to see the whole label and not have to make my columns too wide to see it. But sometimes we end up picking names that are really big. They sometimes become hard to work with. So that simplified things. But what about these numbers here? Still, program. What's program 4? What's program 6? Program 6 was business. Remember that one. Home. What's 7? Oh, 7 is Nova Scotia. I know that one. That age, that's fine. What's 1 here? That turns out to be a female, and 0 is a male. All of these things, it would be easier. What can't you just give me a table with words? It makes it a lot easier for me to read. And I'm not doing math on it. I'm not doing calculations. What's your average province? They're just words. So they're nominal variables that I've got numbers associated with. So can't I give them names? And that's what we're going to do next. So let me just check to make sure I'm on track with my slides and I haven't forgotten something. Yeah, I'm going to clean things up and I'm going to fix up. Well, I'm going to do program in a minute. And I'm going to recode the program that you're in. So let's go and I'm going to show you how to do that. So here's program. I can't just type over things. I'm going to need to have the old value and the new value. Once I've got the new one, I might be able to get rid of the old one. But just for safety's sake, I'm going to keep both. So for program, I'm going to create a new column. So I'm going to insert a column, and Excel will throw it to the left. Let me make this wider so you can see the names here. So this is one is called program. This new one I created, it gave it a name, called it column 1. I know my new one I want to be called program. But look what it did to my old one. It called it program 2. In a data table, you cannot have 2 columns with the same name. Every column has to be, each one's a variable. Each variable has to be unique. I can't have 2 things, two labels that are the same. So Excel automatically will change the previous one. It gives this one, I intentionally called it program, so it'll do what I told it, and call that one program. It'll fix the other guy. Now the program, I want to go and translate this number into a name. And I've got a whole bunch of descriptions here for program. Here it is. I've got all of these different labels here. Okay. And some that I don't have at St. Mary's that they're again problematic. That I would like to assign labels, not as long as these ones, these are too long, but with each number. So with 1, I'd assign education maybe to visual performing arts and give those names, but it isn't exactly what I want. I'm going to go and make up a slightly different table. This is the one I'm going to use. So ignore all this stuff that's over here on the right. Just look over here. What I did was 1 was education. We don't teach education at St. Mary's, so I'm going to call it invalid. I could have thought that student probably is an art student wanting to become a teacher and called this arts for that student, but I don't know. Guessing can be dangerous. 2 is visual and performing arts. I really don't know what to do with that one. Let me call it invalid. But some students may have seen, oh, that says art. I'm in arts. And they picked it for that reason. Third one is humanities. And the fourth one is social sciences. And a lot of students aren't quite sure which is which, but they know arts is humanities and social sciences. And some aren't too clear on that either. But I'm going to lump them both together. 5, I think, was medicine. And I don't know what to do. Maybe it's a science student, a biology major, but I'm going to make it invalid. 6 was business. I'm just going to call it business, not they gave administration or public administration or management. 7 is physical or life sciences, like chemistry and biology and the like. Science, easy. This is math and computing science. I'm going to just call that science. We have an engineering program, so I'm going to keep them separate and call that engineering for 9. It's a small program, but let's keep it separate because they're going for a different degree that's done partially at St. Mary's and partially at Dalhousie. 10 is several different groups, but part of it is environment. And in 2010, we still do have an environmental science program within science. We now have an environmental studies program in arts, but we didn't have that back then. But these were science students, no doubt. A bunch of the others, again, are ones we do not offer, and I'm just going to make them invalid. So I'm going to convert these numbers to these words. And how do I do that? This table we call a lookup table. I look up a number in this column, and it gives me a new value in the other column. And very often when we're recoding things, we use lookup tables. So let me go back to what I'm trying to do here. I want to recode it. I'm using essentially a formula to do this recoding. To start any formula in Excel, you have to type an equal sign, equals. The procedure in Excel for doing this lookup table is called Vlookup. So I type Vlookup. Oh, there it is. Okay. It takes the old value and it just wants to know where is the old value. The old value is over here in D2, right in that space. So that's D2. I need to give it the table as to how to do the converting things. So this is the lookup value. Now it needs to know where's the table. Well, the table, I don't put in my data sheet. I put it in a separate sheet with lookup tables. So I've got a separate sheet here of lookup tables. This is one I just built in here, just typed it in. So here is my lookup table. It goes from A2 here, down here to B15. You'll notice here's my formula. It's still there. I've changed sheets, but my formula that's back in another sheet is still showing up here. So it has VLOOKUP, has the D2 that I'm going to be looking at. Look in the lookup tables sheet and use this table for doing it. Now, I'm going to do this twice. The new value is in the second column. So I put in a 2. And there are 2 types of matches it does. One's called approximate and one's called exact. And we'll explain approximate later. These ones are exact. A 4 is an art student. Exactly. It's not approximately. They aren't almost an art student or mostly an art student. They are an art student. So we're going to use exact match. Whoops. Sorry. And for some reason, Excel says that has to be called false. Whoops. Boop, boop, boop. Somehow I've got other junk thrown in here. Okay. And when I hit enter, I get thrown back. And this is what it did to me. It took the 4, made it an art student. 4 art, 6 business. Is that right? Not sure. What are all of these not applicable? It went and changed everything down in that column. If you remember the formula, it said that the table I'm going to use goes from A2 down to B15. Notice, and that's what it is, A2 to B15. But here it says, whoops, this one says A3 to B16. This one says my table is in A4 to B17. My table kept moving. Excel is guessing as to how that table is supposed to be, and it thinks as you move down rows in other tables. No, we're not supposed to do that here. So let me go back and fix it. Go up here. I want to fix that this table is always starts in column A, always starts in row 2. I'm putting in dollar signs. And this, it ends in column B and in row 15. So I manually am putting these dollar signs in. There is a shortcut if you've got a PC. If you pressed F4, it would have put those dollar signs in for you. My keyboard at the moment is defective, and so I can't use it. Now that I've put the dollar signs in, let's try pressing enter again. And now it's done it correctly. So it's classified these invalid guys down here appropriately, put the other ones into their appropriate programs. So Vlookup is a nice tool for doing this. So we need a lookup table, and then we have a process for doing it. I've already done it. If I jump to another sheet in a minute, because I'd like to recode home, where they're from. I'd like to recode gender, parents' education, and language. So I've got tables for each of them. So I'm keeping all of these tables in one space. So I've got them all organized in this fashion. And I went and applied that all across the board. Okay. And I'll just jump to what happened. And here's a recoded. Hopefully I've got everything right here. So this first student that was in arts is from Nova Scotia. Their home was 7. Ignore column K for the moment. I'll explain that one in a few minutes. Now, this student didn't tell me their gender, so I've got it blank here. They also didn't tell me their parental education, but it isn't showing up as being blank. It's showing up as being not applicable or not available. What happened there? And for language, they didn't tell me what their first language was, and I've got junk being thrown in here. So here, blanks are putting this stuff in. In this one, I've got gender that's blank, and it's giving me something else. And it's because I did something with this. With gender, the formula I put up here is more complicated. And I'm going to go and put it back the way it should have been if I was just doing this simple formula. Okay? So here I've got VLOOKUP. If O2, I'll take the value in O2, I'll look up in the lookup table. Here's my lookup table. I look up matching here, and the new values in the second column, it's an exact match. I'm using false. And so if I put that in, which looks right, press enter. Whoops. Oh, I got too many columns here. Excuse me. Oh, excuse me. I've got to take this bit out. I must have accidentally typed that in there. There we go. I should be okay. There we go. All right. It didn't put not applicable in there. It put male in there. So if I don't know your gender, if you didn't tell me, I'm going to assume you're male. Do you know what happened? What went wrong? Why did Excel decide to call these people that didn't give me an answer all men? They thought it was a zero. That Excel will interpret, not all the time, but frequently it interprets blanks as being zeros. And in my lookup table, this one was a different one. Notice these ones, I've got numbers 1 to 14, 1 to 7, 1 to 3. This one has a 0. And it took what I put in there for 0 and it assigned that label. So if I want to fix that, I can. And it's another feature within Excel that you can use if you're trying to clean this up. And you may or may not. This one, I can deal with the not applicables. I know that means blank, but I can't deal with this. This is a serious problem. These are not, some of them may be male students, but not all of them are. And it's going to mess up my analysis in comparing males and females. So what I'd like to do is I can put in an if statement in certain cases. If an if statement says if, and you state a condition that's either true or false. And if it's true, what do you do? If it's false, what do you do? So if that O2 was actually equal to a blank, what does a blank look like? It's like, oops, another quote. So there's nothing in between there. It's empty. There's no text, no space, no nothing. So if it's equal to a blank, I want the new value to be another blank. But if it's not a blank, I want you to use Vlookup. And I'll put a bracket on the end here. Oh dear. I hope this works properly. I'm not doing it on the first case. I'm doing it there. Yeah, see, it didn't fix this case up here. Ah, fixed all the ones below it. That should work. What am I doing wrong here? Usually when you're going and fixing things, let me just go back and undo all this stuff. Okay. What are they doing to me? Excuse me. Okay. Here's where I was at the beginning. Always, when you're putting in a formula or this type of thing, do it with the very first entry and it'll do it for all the ones afterwards. If you do it elsewhere, it sometimes does strange things. So I'm going to go back and do this again. If oh yeah, that's why, because I said O2 before. Messed up my formula. That's what happened. There we go. All right, now I'm safe. Everything works. Okay. That so this is a tidier one. So be careful on these things when you're doing this recoding process. So what am I supposed to be telling you about? Stage. So we went through, we did program, we did the recoding of it. We asked our questions about these strange values that were coming up. That I went and yeah, it was in C2. These were the different steps I went through in fixing it. And that's how I recoded program. And as I said, there are some errors that we saw within that, programs we didn't offer. That I did the others, and we just looked at this problem of zeros and ones, or the zeros and the blanks. Okay, and that was fixed. So the last thing I want to do is what I call an approximate match. So when we were doing this thing, I was saying, look, if you're a 4, you're an art student. No question, you're not approximately an art student. What would we mean by an approximate match? Approximate matches are usually used for translating groups of numbers and clustering them into categories. So if I was looking at expected earnings, maybe I don't care if they said 33,000 or 34,000 or 39,000. It's a number that is a bit on the low side. Maybe I'm going to create clusters and look at who are those that are giving me numbers that are crazy low, very low. Minimum wage in 2010 that uh, if it was a full-time minimum wage job, you'd be earning more than 20,000. So if they're giving me a figure below 20, there's something strange going on. Maybe it's a data entry error, something that I shouldn't be investigating, but these are strange. Maybe 2 years after graduation, they expect they won't be in a job, they'll be still in school doing another degree and working only part-time. Maybe that's what's happening. Don't know. 20 to 40, I might call low. 40 to 60, about average. At that time, the average expectation was around $50,000. So this is sort of the middle. 60 to 80, 80 tends to be rather high 2 years after graduation, unless you're maybe a mature student that's, graduating with your BCom when you're 35. You're already in a decent paying job, and maybe you're up in that range. That 80 to 100, that is pretty high for 2 years after graduation. Sorry, 80 to 120, I think I used. And then above 120, that's crazy. That's a ridiculous number. So how do I do that? This looks like a table, like a lookup table. It's got ranges that convert to labels instead of specific numbers. So it's a range of values to a number. Well, I don't need to give the whole range. This is neat. The first group was 0 to under 20. So if you earn 20, you're automatically into the second group. But if you only earn 19, you're in the first group. And if you earn 33, oh, you're above 20, but you're not into the 40 group. So 33 is still in the low group. I only need the starting values for each group to be able to do it. And this should have been 120. Somehow I messed up some numbers here. So let's make that my lookup table and see what we get. And so I created a new column called salary group and did it that way. So here was my salary column over here and all these values. And I inserted a column to the left and called it salary group. And the formula I put in was as follows. Vlookup, look up $20,000, go to the lookup table. Where's the lookup table? It's in O2 to P7. That's over here. Here's my O2 to P7. And see, I was using 120 for my crazy group. But my slides are wrong. And where am I here? So that was what it was. I picked 2, and then I put in true instead of false. What would happen if I had put in false and did an exact match? There we go. And you'll see 20,000, it's in my table, so that's low. But 450,000 isn't in my table, so it's not in there. 60,000 is in there, but 90 isn't. 40 is, but these other numbers aren't. 0 blank is in there, so it gave a value. So with an exact match, it would only take those specific numbers and it would ignore all the other ones. So, but by putting in true instead, why do they call this true and false? I don't know. Why don't they say exact and approximate? Beyond me. But I put in, sorry, let me make sure I do it up here. I want to go up here and I want this. Oops, sorry, it's in there properly, the true. Okay, so it gives me the right descriptors with each one of those ones for those numbers. So if I want to group and cluster my data together into categories, and then I'm going to look at the different categories. And so maybe I want to look at What's the difference between students with very low expectations and those with very high expectations, and just pull out those two groups and study them. This makes it easier for doing that. So instead of looking at the details of exactly what number they put in, I just want to know what general type they are. And very frequently, that's easier for us to do, is to look at clusters or groups. And with an approximate match, we can do that type of grouping. And almost at the end of the story now. That so this, just to flip back, my new table now, if I looked at student 472, started in 2009, that's a first year student in business from Nova Scotia, crazily low salary expectations, only $10,000. It's a young woman, only 18 years of age, doesn't know what her parents' education is, and her first language is English. So it's easier for me to read this now as to what's going on. Um, I haven't fixed up these things about being worried about jobs and concern, that sort of thing. We'll come to that probably later in the course. But for now, at least, we can see how we can then recode it and make it easier to study. We haven't done any analysis yet. We've got to first familiarize ourselves with the data, get to know it, build this relationship with the data before we start drilling into it and finding patterns. To recap where we are, we've done things in Excel, um, creating a new sheet, or copying stuff into a new sheet to make sure that we protect our original data using this table thing that does make some aspects of working with it easier. We've renamed variables to make them more intuitive, used Vlookup and if to recategorize or relabel some of the values. And we've even started aggregating, grouping our data to make it a little bit simpler for doing the analysis. The detail isn't necessary. We don't need to know exactly what number they put down for expected salary, just generally what ballpark they're in. Makes it simplify things as much as possible. Simplify it for you to be able to process, and it may make the type of analysis you do simpler and easier to deal with. If I'm looking at it from a data science perspective, having a data dictionary is essential. I'm surprised how often I've seen data files where there isn't a data dictionary attached to it. They may have it on paper elsewhere, but that gets easy to get lost. And all the paper that had to do with this particular study, I've lost. Keep it all together in the same workbook. Protect your data. Prepare it. Don't rush in to start doing analysis. Make it tidy, easier for doing that type of thing. Be careful with your recoding of things, that it may have unintended consequences, like we saw for male versus female. And as you're doing it, you can't help but start seeing some of the data quality issues, missing values, potential data entry errors or misunderstanding errors. This spreadsheet had 811 rows and has about 100 columns. So I'm looking at potentially 80,000 boxes in there. Wow, a lot to look at. We've only scanned through parts of it, but already we're starting to pick out particular issues. How do you go and evaluate quality on 80,000 pieces of information easily? We'll see with some of the things that we do. We'll spot easy problems to find, but there may be some more complex problems that are buried in your data and can mess you up. But data quality is always an issue, should always be top of mind when thinking through this. Is the data what you think it is? What comes up next is now moving into summarizing that data in different ways and starting to look for patterns. And normally we do need to summarize. We need to know what's middle, what's average. So if you've looked at the discussion question for week 3, it starts Wednesday, what do you mean by average? We talk about it all the time, or we talk about middle all the time. Oh, I come from a middle income family. What's middle income? Someone going to define that? And middle in what sense? If you're talking about low income, what does low income mean? What does high income mean? What's unusually low or unusually high? That gives me a sense of diversity, knowing those sorts of things. So it's usually we need to know more than what's the average, but we'd like to know how diverse our data is. And one way of thinking of diversity is what's particularly low, what's particularly high. What's an outlier? Who's really, really, really strange? Um, those are sometimes just very strange cases, but other times are errors. Like expecting to earn $450,000 sounds strange. Um, and can we summarize that pattern that we've seen? Can we summarize it numerically? Can we summarize it graphically? And both have their places. In some contexts, number summaries are good. In other cases, graphic summaries are more powerful. And what are the sorts of patterns we should expect to see? Um, are there specific tools we've got for doing this sort of thing that um, we'll be getting into that over the next few classes, all doing it within what can Excel help do for us in doing that type of thing with the tools that are within Excel. But that's where we are today. That I'll post these slides shortly. I think I may have trouble with recording at the moment. Looks like my recording software is working differently this morning than it was Wednesday. But anyway, uh, and we'll be back in touch on Wednesday. So you guys take care, and bye-bye.